Okay, welcome everyone. So hopefully the quiz went well, and hopefully you still remember your trigonometry that you did, hopefully not too long ago, because there's going to be a lot of that today and for the rest of the course, by the way. So just to let you know, trig is big now. So let's go on and go over the quiz. Okay, so let's do question one first. And hopefully you all recognize question one. Okay, the numbers are different probably because they're randomized, but the words are the same. So suppose P of T represents the population of a certain mosquito colony where T is measured in days. The current population of the colony is known to be 556 mosquitoes. That is P of 0 equals 556. If P prime of 0 equals 170 mosquitoes per day, estimate the size of the population in 18 days. Show your work. All right. So the whole point of this is you estimate something by looking at the tangent line. So what we need to do is find the equation of the tangent line. So let me ask you, and this should be easy, what's a point that the tangent line goes through? The hint is it's easy.
556 and 0.
0, 556 though. So 0 is first, so 566 is second, right? Because it's time, comma, mosquito numbers. So 0, comma, 556. And what's the slope of the tangent line? That should be easy also.
$17 or 170.
170, yeah, 170, because remember the slope of the tangent line is the derivative at that point. So we now know the slope, we now know the point, and not only know a point, but it's the y-intercept because it's x equals 0. That makes life really easy. So that means that y is equal to mx plus b, 170 x, actually t, and maybe I'll put p, use the letters they used. Okay, so p is, and it's not quite equal, so let me fix that because it's really an approximately equal to. So let's write this out. P of 0 of t is approximately equal to, and then it was 170 t plus 556, if I remember right. Any questions on that? Okay, and what are we asked to do? We're supposed to use this to estimate the population in 18 days. So this is very easy. What do we have to do?
Plug in 18.
Yep, plug in 18. Nothing tricky. So I plug in 18. And what is that? 170 times 18 plus 556. 170 times 18 plus 556 is 3116. Any questions on this problem? Any questions at all? So far, so good?
I got 3,616.
Maybe I read it wrong. Just a minute. 170
Yeah,
times 18.
you're missing 500 there. Yeah.
Yep, I typed it wrong, I think. So what happens when I go from screen to screen? It's 556. I missed a 5. 3616. Thanks. Okay, so now let's move on to the second one.
There, actually, I had a question on this. I'm not sure if it's
Sure.
legit. So, I mean, I got the question right, but I felt like with the way it was read or wrote, it looks like P prime of 0 equals 170. Couldn't you assume that P prime of like 1 would be different, and therefore the whole equation might be like exponential or something, or the rate might change? Is that just the
Absolutely.
way I read it?
Absolutely, except there was one word. Fortunately, you got the right answer, but there's one word you may not have paid attention to, and that's right here, estimate.
Ah, gotcha. Okay.
Right. So if we're estimating and all we know is the point and the derivative, the best we can do for estimating is to use the tangent line. Does that make total sense?
Yeah, absolutely.
If I said find the exact size of the population in 18 days, your answer should be screw you, I can't. Does that make sense?
Oh yeah.
But calculus is used to estimate things. Okay, because remember that the derivative is the equation that is the slope of the tangent line, but life is not a line. But the idea is if you don't go too far away, you're usually a pretty good estimate. If you go very far away, then you're not a good estimate. And kind of, when you look at it, 18 may not be that far away, or it may be, really depends. Okay, it depends on what kind of rate of change things are, but it's just an estimate is all we can do. Okay. All right. On the other hand, part question 2, we'll be able to answer everything exactly. So a bird is flying and its altitude, A of t in meters, as a function of time is A of t equals 3t cubed minus 4t plus 12. Okay, when is the bird neither gaining nor losing altitude? Okay. In calculus terms, what's another way of saying this question? What's the calculus way of asking this instead of the word problem way? When is a bird not moving? There we go. I like rivers. When is the derivative 0? Because derivative is the calculus word in our class. And remember that gaining or losing, that's a rate of change. And if it's not gaining or losing, that means the rate of change is 0, which means the derivative is 0. Any questions on that? Okay. Yeah, so just a reminder, in case you have to leave early, this is recorded as long as, technology doesn't destroy it. I will record it and you can always watch later. Okay, so what we need to do is we need to take the derivative. All right, and I tried to give you one that's not that hard. By the way, here's what you do not want to do for most of the rest of this class. And that is, what you don't want to do for most of the rest of this class is use a limit definition. Okay, that is basically to prove different derivative equations, not to do applications. So we need to find the derivative, a prime of t. So what's the derivative of 3t cubed? Go power rule.
9t to the second power.
Yeah, it's 3 times 3 times t, 3 times 3t squared, or 9t squared. What's the derivative of minus 4t?
Minus 4.
Minus 4. And what's the derivative of plus 12? 0. So a prime of t is 9t squared minus 4. Now we want to find out when it's neither gaining nor losing altitude, so we take the derivative, set it equal to 0. So let me just write down equals 0. And I tried to give you one that was very easy in terms of the math. So you'll notice there's some nice things about 9 and 4, and they're both perfect squares. That's not a coincidence. So then we solve, and I'm going to do it in my head. I'm not sure if you can, but you might be able to. Add 4 to both sides, divide by 9, and you get 2. You get 4 over 9 is t squared. Take a square root, and you get 2/3. And I guess technically, I don't think I grade off on it, but technically, you would say that t equals 2/3 or negative 2/3. So technically, there's 2 answers to this, because they'll both give you 0 when you have a derivative. So that's why I won't take off points, because can it be negative? Technically, yes, because in the question, it does not say that t has to be positive. So the question is, can time be negative? Do you think there was existence 5 years ago? Sure. I was younger. You were all younger too. So time can be negative. Okay. You can't be, I think the domain is something like negative, something like 13.1 billion years or something like that. And you can't get less than that, but I'm not going to get involved in that. It's a little complex. But time can definitely be negative 2/3. Any questions on that? Okay, B is, what is the bird's acceleration as a function of time? So what do you have to do to find the acceleration?
Take the second derivative.
Yeah, take the second derivative. And the nice thing is we've already got the first derivative. So we can get the second derivative quite easily. So I have a prime and I want a double prime. Oops. There we go. So a double prime of t, what's the derivative of 9t squared?
18t.
18t. What's the derivative of minus 4?
0.
0. There's our acceleration. Okay, and maybe I'll write, I'll just leave it at that. And that's our answer. Any questions at all on this example? Any questions? Okay, there's no questions. Let's go back to our schedule of things to do. And the next thing, are there any questions about anything? This is your chance. And also your chances afterwards when we're have office hours, but you can ask now too. If you have a question, it's not too long.
I have a question, if I may ask.
Sure.
So I was having a lot of difficulty with both number 9 and 10. I mean, they're very similar, but I didn't understand how, with both problems, how it led to the answer. And I tried to use my notes as best as I could on the homework, but I couldn't figure it out.
Yeah, so a couple things. One, I don't have it memorized. The other is if I did it, it's somewhat random anyway, so memorizing doesn't help completely work, even if I did have it memorized. Maybe you can read it, and I'll give you some hints on it, and then we can go over all the details after.
Okay.
Do you have it in front of you?
No, I don't have it in front of me, but maybe I'll ask during office hours.
Okay, yeah, if it's going to take a while, then office hours are probably the way to go.
Okay.
And I definitely can help you on office hours. I mean, I could help you now if you knew right away, but I don't want to waste, 20 minutes looking for the problem or something.
Right.
But definitely office hours are good for that.
All right then.
Other questions?
I actually remember that problem and what was going on, but yeah, if you want to keep moving on with class, you're a fifth away from it doubles because if it triples in 10 minutes, it doubles in at 5 minutes, and then you're a fifth away from that rate basically. Because like
Wait, if it doubles in 5 minutes, it triples in 10, or is it quadruple?
Yeah, it triples. It's weird. I that's how I figured it out.
Okay.
And I got it right. So
Uh-huh.
I don't know. Yeah, it's like you're 1/5 away from doubling.
I see. Yeah. Yeah. So the idea here is you're given something about the equation, and if it says it doubles in a certain amount of time, then what you can do is you can say, well, it's very similar to the one I just did, where you find the equation of the tangent line by knowing it doubles. So that means that you're where you are at time 0, and then you're double at time whatever the doubling time is. And then you find the equation of the tangent line between those 2 points. And then if you want to find out when it triples, then you triple your initial, and that'll give you your y, and then you solve for x in the equation of the tangent line. I don't know if I lost you there, but that's kind of how you do that. I could go over the details in office hours. I think that might be the best, but that's kind of how you do a problem like that. Okay, other questions? Okay, if there's no questions, let's go into trig. Some of you, that's a good thing. Some of you, that's your terror, but we're doing it, and trig is important. So first thing, when does trig happen in the real world? And that might be, your career in engineering or healthcare, or business or whatever you're doing. Any thoughts? When do you think trig occurs? GPS. Trig occurs in GPS. It's a little too complicated for me to talk about because GPS is 3-dimensional, and there's a lot of trig in 3-dimensional, and it's spherical. But a little more complicated, that'll be third quarter trig, third quarter calculus. Yeah, so if you're doing electromagnetic radiation, so for example, I don't know if you realize, but right now we're online, and I don't know if you realize what's going on, but you're hearing my voice, and my voice, do you think there's trig in my voice? And yeah, the answer is absolutely, absolutely. So if you got sound, it's sound waves. And if you got sound waves, you got to put that through a transmitter. You got to send those waves through the transmitter. You do what's called a Fourier transform on it, which truly turns it into trig, picks it up on your side. It does a reverse Fourier transform, and then you hear it. So just let you know that there's, if you're doing a transmission of pretty much anything, whether it's waves or light, all of that electronic stuff is all about waves, and waves are all about trig. Okay, how about in the biological world? When does trig happen? And it happens lots of times too. So in regular biology and health science. Any ideas? It's happening right now to you. If not, you're dead.
Mitosis? I don't know.
Mitosis, yeah, cardio, your heart's beating. Okay. Anytime you have something periodic, and you better hope your heartbeat is periodic or you're going to be dying soon. Anytime you have anything periodic, you model that with trig. So the heartbeat, I think you all know, is a periodic pattern. Okay. And it has a frequency and it has an amplitude. And then you can drop trig into it. Does that make sense? Trig happens everywhere. In business, where do you think trig happens in business?
The market.
The market? A market? Yeah. And how come in the market? Maybe market?
Because the chart fluctuates depending on the price and how it ranges in lows or highs.
Yeah, but let me tell you where it is because I think you're not quite getting at it. Quarterly returns. So I don't know if you know, but in the market, every 3 months, there is a quarterly report that every corporation has to give, and that quarterly report will change the market patterns. And so what you get is you get some periodicity. It's a noisy periodicity, but there's some periodicity in the market because of quarterly returns. So when you get advanced about economics, you figure that stuff out. Okay, so in the banking industry, then it's tend to be monthly. People tend to go to the bank when they get their paycheck or deal with banking stuff. And that's, most people get paid every month. Some people get paid every week. But either way, it's every something, and that is going to be trig because it's periodic. And anytime you have periodic anything, you typically model it with trigonometry. Any questions on that? So it's everywhere. So I do want to mention that this isn't just some crazy thing that mathematicians like want to be sadistic about and give you hard stuff. It is necessary for so many different applications. So I'm not going to do all the applications. We'll do some, as we go. But let me remind you some trig. So first, I hope you remember that sine of x and cosine of x are the big trig functions. Hopefully you all remember that. And again, I'm not going to do a full review of trig because I can only do so much, but I'm going to do the things that I expect you to have forgotten. So my guess, maybe I'm wrong. Does any of you remember this formula right here? Sine of a plus b equals sine of a times cosine of b plus cosine of a times sine of b. Be honest, anyone remember that? Now the double angle is the next one, actually. This is the sum of angle formula. Yeah, back to pre-calc. But we're going to be using this today. The other one we're going to be using today is sine, the double angle, is sine of 2x equals 2 sine of x times cosine x. Okay, and by the way, just a note, I use the letter x or letter A and letter B. Hopefully you're at the point of math sophistication where you realize you can use any letter you want. Okay, you want to use the letter that is the most convenient and tells a story the best. So X is the one where it's just math because you have nothing to say. Sometimes you use theta if it's an angle. You've probably seen it as a sine of 2 theta maybe. But it doesn't matter what letter we use. What's the big letter that we should stay away from in this class as a variable? D, yeah. You do not want to use D. E we're going to stay away from, but we don't know, but we haven't actually touched it. We're going to be doing that next week. So E is definitely one to stay away from, but that's next week we'll learn why. We haven't actually talked about e to the x yet. That's a big E, by the way. But it won't happen for, I think, a week, next week. But D, we should all know that's a variable that you should never touch, okay, in this class. So X is a good one. I want to remind you about something else with sine and cosine. What are the units of angle measurement for sine and cosine?
Radians.
Radians, okay? If you use any other units, everything we do does not work. Got it? Okay, so just let you know, you must use radians or nothing we do today works. Okay, then I'm going to show you some review, and this is not a review of trig. I mean, it's a review of trig, but it's not a review of pre-calculus trig. It's a review of our class trig. The first was a limit as x goes to 0 of the sine of x over x was equal to 1. Do you remember that? Okay, and by the way, if you choose a unit that isn't radians, you don't get 1. So that's one of the big reasons why you got to use radians, because radians are beautiful. They give you nice things. Okay, so that's a really important formula that we had, and we looked at it, we proved it using angles and stuff like that with pictures of triangles, but it all happened. And then the other one was the limit as x goes to 0 of cosine of x minus 1 over x equals 0. Okay, and I think I actually didn't prove that, but it's in the book. I can only prove so many things in the class. Any questions on some of the trig stuff we're about to need to use. Any questions? Okay, so if there's no questions, what we want to do next is we want to say, well, let's go to the first trig function. And I don't know, it's kind of a tie whether you want to do sine or cosine, but I'm going to do sine. And it turns out sine's a little easier in calculus for the proof. So I'm going to do sine. And let us see, how do you find the derivative of the sine of x? Just a note, this is always fun. I'm hoping you all know what the graph of the sine of x looks like. Okay, so you all know that hopefully. And by the way, notice Desmos, by the way, if I type in sine of x, I didn't do anything fun. I just literally did Desmos.com. What measurement is it using? What angle measurement? Desmos is using radians, okay? And that's because radians are the way to go, period. Okay, so there's the sine of x. So what I want to do is I want to just kind of look at the graph and see if from this graph we can say what the derivative is. Well, let's start at 0. What is the derivative about at 0? Again, you want to look at the tangent line, and you want to say, what is the slope of the tangent line for sine of x at this point, at the point 0, 0? What does it look like? What does that slope look like? Okay, yeah, 1. Okay, should look a lot like y equals x and has slope 1. So that means that if I'm going to be graphing the derivative, well, it should go through 0, 1. So let's plot that point. Okay, let's plot another point. How about pi over 2? What is the slope of the tangent line at pi over 2?
Zero.
0. It's a horizontal tangent. So that means that pi over 2, parentheses, pi over 2, we have pi over 2 comma 0. Got it? How about over here at 3 pi over 2? What's the slope of the tangent line at 3 pi over 2? What does it look like? Yeah, it looks about like -1, doesn't it? Let's plot that point. So 3 pi over 2, comma -1. I make a mistake there. Oh yeah, that's fine. Wait, sorry, that wasn't 3 pi over 2. That was pi. That was so -1 is not at 3 pi over 2. That was an error. So that point is not 3 over pi over 2. That is at pi. Pi comma -1. Any questions so far? Now at 3 pi over 2, that's here. That's horizontal, so that's 0. How about at 2 pi? Well, it better be back. It's periodic. So if the derivative was 1 at 0, the derivative is still 1 at 2 pi. Any questions on that? Okay. Now, so does a tangent go through the function rather than touching one point? So the tangent line touches one point nearby. Far away, all bets are off. But if you zoom in, it just touches the 1 point. Okay, unless you just have a line to start with and then it's the same. Then it touches everything. Okay, so now what I'm going to do is I'm going to think about, well, what's going on here? And what does this kind of look like? And again, you'll notice that nearby 1, like over nearby 0, still kind of close to 1. Do you see that, the slope? Slope doesn't really start changing until it gets around here. So it's actually going to kind of hover near 1 and then go down like that. And then it's going to go like that. And then it's going to go like that. And it's going to go like that. What does that kind of look like? Looks like the cosine, doesn't it? Okay. Is that a proof that the derivative of the sine is the cosine?
Good enough for me.
No, it shouldn't be good enough for you. That's not a proof. Okay. It is no proof. But what it does is that way when we're working it out and we're going to get, if we get cosine, then we're going to say, you know what? That's what it looks like. You know, could be something close to the cosine, but turns out it will be cosine. But you can kind of see from the picture. Okay. And we could plot lots more points and it'll get even more looking like the cosine. But I wanted to plot the ones that are kind of easy for you guys, hopefully. And also a nicer view of how the picture works. Okay, so now let's write down the big theorem and then we'll have to prove it. And a lot of times that's how math works, is what you do is you just kind of look at a picture or, you know, watch some kind of thing going on, say, yeah, it kind of looks like this. And then you write that down. Usually you call it a conjecture. And then if you can prove it, then you turn that word conjecture into a theorem. Those are just some language. So the theorem is that that the derivative so d over dx of the sine of x is equal to the cosine of x. Any questions on that? And again, I know it was good enough for you just to look at a picture, but it's not. We need to actually do it. And this is one we can do. So let's do it. So how do you got to prove that this works. How do you find a derivative? Rigorously. Here's a hint, 3 letters. Yeah, so we're going to take a limit as h approaches 0. And then we're going to have the fraction. Number is f of x plus h, so that's going to be sine of x plus h minus f of x, that's sine of x, all over h. Any questions so far? All right, is that, by the way, is sine of x plus h the same as sine of x plus sine of h?
Say that again?
Is sine of x plus h the same as sine of x plus sine of h?
No.
Definitely not. Now, you may not remember because it has already been about 5 or 10 minutes, but I have a formula here to say what happens when you have sine of something plus something. And that is sine of a plus b is sine of a cosine b plus cosine of a sine of b. So we need to use that formula. We're going to turn that sine of x plus h into sine of x cosine. So again, if you go here, it's sine of a cosine of b. So sine of x times cosine of h. And then plus, and then it's cosine of x sine of h. Any questions on that? Any questions? Okay, then the next thing I'm going to do is I'm going to break this into 2 pieces. Even though it looks like I should break it into 3 pieces, turns out 2 is the way to go. So what I'm going to do is I'm going to rewrite this, and I'm going to say, well, I'm going to have the part without the cosine x sine of h. And then plus the part with it. Any questions on that little tricky algebra? Okay, now what I can do is I can take what I've got over here and look at the numerator, the very first numerator. What could I do algebraically? Combine like terms. We don't really
Factor
have
out
any
sine
like
x.
Yeah, we could factor. Yeah, we can factor out sine of x. So what I can do is I can write sine of x times parenthesis cosine of x minus 1. And for the next one, I'm going to take that cosine of x. It's not really doing anything, but it'll help. And I'm going to kind of take it outside the fraction, right? A times b over c is a times b over c. That's all I did. Why is that helpful? And by the way, I could take that sine of x and do the same thing. Why is that good? And the hint is, if we go up here, I gave you a little review of what we did with limits in trig. Yeah, we know sine of h over h goes to 1. And what about cosine of h minus 1 over h? And that's the hint, is we had that right here. Except it's an x, a letter doesn't matter. Whether it's an h or an x, it doesn't make any difference. So cosine of h minus 1 over h, as h goes to 0, goes to 0. Got it? So what we get 0 plus cosine of x, which just happens to be cosine of x. And that's the full proof. And that's good because when we looked at the picture, it looked like it might be cosine of x. Okay, again, you can't know for sure just by kind of looking at a picture, but at least what we got makes it looked right, and that's good. Okay, and again, a major warning. If you're not in radians, this is false. The derivative of the sine of x is only the cosine of x in radians. Otherwise, it's messy. And I don't want to get into messy, so let's just stick with radians. Sound good? Any questions at all on this big theorem?
Yeah, Larry, I'm not following on the where you get the -1 cosine of h -1. Did you factor out the sine of x to get that -1?
Yeah, so notice in this, I have a sine of x times
Over
cosine of
8.
x minus sine of x times 1. Right? You could always write sine of x as sine of x times 1.
Mm-hmm.
And then if you factor the sine of x out, you're left with a cosine of h, because that's on this side of the sine of x, and then -1, because that's on the other sine of x.
Okay. Okay. Thank you.
Yeah. So I literally didn't do calculus, I did algebra. Most of the hard stuff in this class is algebra. And trig, by the way. Okay, but good questions, because again, a lot of algebra is happening. All right, I want to let you know that this is my responsibility now, not yours, till the final exam. The final exam, we're back to limits again, and you have to do them. Okay, your responsibility is the following. memorize the theorem. Not the proof, but the theorem. In fact, it's so important. I'm going to write it down again. The derivative of the sine of x is equal to the cosine of x. Okay, you got to have that one down. And what's nice about it is it's not messy at all, is it? Okay, it's not.
Not yet.
Yeah, it's not yet. Actually, we're not going to have a lot of messiness. I think the quotient rule might be the messiest of the calculus that we do in terms of things you have to memorize. And that's why I made a poem out of it, because it's messy, but with the poem, then it helps a little. And I didn't come up with the poem, actually. The poem was, I first heard the poem from another student in my calculus class when I took it at UC San Diego, like 30 years ago or something. So it's been around a long time, this poem. And I don't know where that person got it. He said he got it from his high school teacher. So I don't know. But derivative of the sine of x is the cosine of x. I will let you know that the memorization gets harder next quarter, because all of a sudden you have to do everything backwards and you got all these minus signs that are switched and stuff. This quarter's not so bad. So let's do an example. And let's see if you can do it, and then I'll go ahead and do it too. Find the derivative. So maybe I'll write it this way. Find x squared times the sine of x prime. So what is the derivative of x squared times the sine of x? Let's see if you can do it. It's not that hard, but you have to bring together what we did today and what we did on Monday. So I'm going to give you a moment. It shouldn't take more than a minute.
Is it 2x times the cosine of x?
Not quite. You got to remember what we did on Monday. So put in the chat box is probably best. That way it'll take time. So the hint is you have to remember what we did on Monday or you're not gonna be able to get this.
Yeah, I forgot the product.
Yeah, that's it. That one's one of those. That was another memorize this. There are some things to memorize in this class, and that was another one. And you can pop in the chat box. It's 2x. Good try though. Give you a little bit, and then I'll do it. All right, let me remind you of the product rule because it looks like some of you might have forgotten it, and please get that down. So the product rule says that if we want to take the derivative of f of x times g of x, that is equal to the derivative of f of x times g of x plus f of x times the derivative of g of x. Okay, you got to have that one down. Yeah, very important. So let's see if you can get it. Good, good. It looks like we got one person. So again, f prime of x is 2x. So f prime is 2x. Good. And the order you write it doesn't matter. So 2x times g of x, which is sine of x. And then plus f of x, which is x squared, times g prime of x, which is cosine of x. Any questions on this example? Any questions?
Would that be it? Like, I don't have to do the algebra? Like, that would be considered the answer? Just doing the
What algebra would
calculus?
you even like? What algebra would you even like to do here?
Well, I guess you're right.
And I guess you could factor out an x, but I don't think that's any better. Yeah, so remember my rule of this class. So maybe I should repeat it again. What's the rule of this class in terms of like on exams and quizzes?
Just do the calculus?
Yeah, you have to do the calculus. And once you're done with the calculus, all that's left is algebra, and you don't have anything else to do with it, then you're done. Does that make sense? Yeah, so that's kind of the rule of the class. Doesn't mean you don't have to know algebra, because sometimes you have to do algebra to do the calculus. Or sometimes there's like, you can do the second derivative, and if you don't do algebra, then it's going to be too hard to even get to the second derivative. But once you've done the calculus, you're done, and I see 2x sine x plus x squared cosine x, there's no primes there, right? There's no derivative notation anymore, so I must be done. Is that clear? Okay, let's do another example. So let's find the derivative of one minus the sine of x in fact, let's make it 1 minus 2 sine of x over 3 minus 4 sine of x. All right, give you a minute or two. Let's see if you can work that one out. So 1 minus 2 sine of x over 3 minus 4 sine of x. And again, if you don't remember what happened Monday, it's pretty much over for you. So I'll give you a minute or two. Shouldn't take too long. It's a little messy. Remember, you don't have to simplify. And trust me, you don't want to simplify. Okay, remember, you don't have to do any simplifying. That's the rule. You have to find the derivatives and not have any primes when you're done. Okay, at least we got one answer there. Let's take a look. So what we're going to do is we're going to do the poem, right? Low d high minus high d low, square the bottom, and away you go. So the low is 3 minus 4 sine x. D high, so the derivative of 1 minus 2 sine x will be negative 2 cosine x. If there's something you don't understand, please ask. So the negative 2 stays, and the derivative of the sine of x is cosine x. And then we're going to have minus high, which is 1 minus 2 sine x, times d low. What's the derivative of 3 minus 4 sine x? That'll be negative for cosine x. Square the bottom and away you go. So 3 minus 4 sine x. Quantity squared. Okay. Do we need to multiply it out?
No.
Definitely not. Okay. You have better things to do with your life than that. Don't you agree? Okay. And that's it. We're done. Okay. There's not really any work to show. But again, you get it, or you remember the quotient rule, or you don't remember the quotient rule. And you do
Larry,
want to be real careful with parentheses. Yeah,
oh, sorry, I have one question.
sure.
So for the f prime of x, the 1 becomes a 0, right? Because it's a constant, but then the negative 2 stays because it's part of the trig.
Yeah, because it's multiplied. So remember that when you add a number and take a derivative, you get 0. When you multiply a number and take a derivative, the number stays. Do you remember that? So the derivative of a plus f of x is f prime of x. The derivative of a times f of x is a times f of x. Does that help? So again, if you're adding a number, it goes away. If you're multiplying, it stays. And that's very important because it happens all the time. Okay, what I want to do next, and this one I'm not going to prove today. Mostly the reason I'm not going to prove it today is that there's such a better way of proving it, and we need Monday stuff. But I can write down the theorem, and it's going to be important. And in fact, let's look at Desmos. So I'm going to start again. And let's look at cosine of x. By the way, if all things are good in the world, what would the derivative of the cosine x be? Right, the derivative of the sine of x was cosine of x. What do you think the derivative of the cosine would be? All right, but are all things in the whole world good?
No.
No, sorry. And this is one of the hardest parts of calculus. Okay, it's not like really messy, but so many people have trouble remembering it. So let's do some pictures. Okay, at 0, what is the derivative at 0? What's the slope of the tangent line at 0? 0.
0.
So we know it goes through 0, 0. So far it looks like sine of x, doesn't it? With 1 point. 1 point's not enough to be sure. At pi over 2, what's the derivative at pi over 2? What's the slope of the tangent line about? What does it look like? -1. All of a sudden, it's not the sine of x, is it? Okay, because the sign goes up, it doesn't go down. Okay, at pi, what's the slope of the tangent line? What's the derivative? Zero. So we get pi comma 0. At 3 pi over 2, what's the slope of the tangent line?
One.
1. So we can plot that one. Okay, at pi, what's the slope of the tangent line?
0.
0. That's not pi. 2 pi is what I meant. Because that's where we are. Okay. So you look at this and it goes down and up and then down, and it's periodic, so it's going to keep doing that. It's not the sine of x. What is it? What do you think it is though? Because sine of x goes up. But it's kind of looks like a sine of x-ish. Yeah, negative sign. Okay. So that's the big theorem. And I'm going to prove that when we have the chain rule. And the reason I want to wait till we have the chain rule to prove it is that it is literally a 5-second proof. And that's if I go slow. But unfortunately, we don't have the chain rule. If I do without the chain rule, it's more like a 5-minute proof, and I don't want to waste your time. So the derivative of the cosine of x is equal to negative the sine of x. And that negative is a pain in the butt, but it's math. It's not like we can change it. So it's what we have to deal with. And it gets even worse next quarter. Okay, so just realize that. That'll be Bruce's problem. Okay, any questions at all on this big theorem? All right, need to memorize this. So the derivative of the sine of x is the cosine of x. Derivative of the cosine of x is negative the sine of x. Okay, what is the derivative? This one's going to be a little tough. You know, it doesn't look too bad. What's the derivative of the sine of 2x? What's the problem with this? Is the sine of 2x just 2 times the sine of x? Can you just pull the 2 out? Definitely not. Anyone know what we can do? Any suggestions? The hint is I showed you before your quiz. Okay, and then right after. Yeah, we can use the trig identity called the double angle formula that says that the sine of 2x, forget calculus, the sine of 2x is 2 times the sine of x times the cosine of x. So I can write this as 2 times the sine of x times the cosine of x. And now how do I find this derivative? Yeah, product rule. So that's going to be equal to 2 times the derivative of the sine, which is the cosine of x, times the cosine of x, and then plus 2 sine of x times the derivative of the cosine of x, which is negative the sine of x. Okay, and there's ways of simplifying this. It turns out that if you simplify it, I'm not going to give you all the details, it is 2 times the cosine of 2x. Because I'm sure you all remember your half angle formulas with cosine, right? Just kidding. Okay, how about this one? This one's a fun one. How about the derivative of the sine squared of x plus the cosine squared of x. How do we do that one? Not quite, River. The hint of this really, really easy. It's just 0. Why is it 0?
Derivative of a constant is 0.
Yeah, sine squared plus cosine, sine squared of x plus cosine squared of x is equal to 1. And the derivative of 1 is 0. And that's it. So all those trig identities are going to be important. Any questions at all on this? Any questions? Okay, and by the way, we're not done with trig. Basically, I'm showing you this, and then for the rest of the quarter, we'll have trig. So, don't just hope it's going to go away, because it won't. And next quarter, even more so. So trig just stays. Does it ever go away in math? And the answer is yes, but only if you become a math major. Okay, now you can't avoid circles and waves, but you can avoid trig even with circles and waves, it turns out. But you have to deal with complex numbers. So just trust me on that. And we're not doing that. In this class, we don't do complex numbers. And it makes some things easier, some harder with trig. Okay, so these are some examples of sine and cosine. So are there any other trig functions besides sine and cosine? What do you think? Yeah, tangent. So let's find derivative of the tangent of x. And the nice thing, I could write it as a theorem, but really I'm just using what we've already done. So d over dx of the tangent of x. Well, how do you do that?
Would you start with sine x over cosine x?
Exactly, because that's the definition of the tangent of x. That's all we got to go with. So let's use sine of x over the cosine of x. And then we need to do that. What rule do we have to use?
The low d high minus
Yeah,
high d low?
square the bottom way you go, quotient rule. So low is cosine of x. The derivative of the derivative of sine of x is cosine of x. So that becomes cosine squared of x. And then minus sine of x times the derivative of the cosine of x. What's the derivative of the cosine of x?
Negative sine x.
Right. So this minus becomes a plus. This sine of x becomes sine squared of x. Square the bottom, cosine squared of x, and away you go. But this is just screaming to be simplified. Do you agree?
Yes.
What's the numerator?
1.
1. Cosine squared plus sine squared is 1. You got to memorize that. Okay, that's the most important trig identity of all identities. 1 over cosine squared of x. Just note, this is not the way anybody remembers it, because it can be written in a prettier way. What's 1 over cosine squared of x?
1 over, or is it secant squared?
Yeah, secant squared. You want to memorize this. But it was an easy proof, actually. And I had to use the quotient rule. Any questions on that? Okay, are there any other trig formulas or trig equations, trig functions, I guess I should say, besides sine, cosine, and tangent? What else is there? Yeah, how about the cosecant? Well, we know how to do that. So the cosecant of x is equal to, who remembers the definition of the cosecant?
1 over sine x.
Yeah, 1 over the sine of x. Okay, and we can use the quotient rule. I will let you know that you don't really want to use the quotient rule for this if everything were good, but you have to today. But it turns out after Monday, you would never use the quotient rule on this. There's a much easier way. So it's like painful for me to use the quotient rule on this. So I'm going to anyway because it's all you know, but that's going to change Monday. All right, so it's low sine of x times d high. What's the derivative of 1?
0.
0, it's gone. So then minus high, which is 1, times d low, which is cosine of x. And then square the bottom and away you go. Okay, we could rewrite this first as a negative. How do you write this without any fractions?
Would be tangent times secant or cosecant.
All cos. So it's the cosecant of x times the cotangent of x.
Oh yeah,
And it's
yeah.
negative.
The cosine's on top, so cotangent.
Any questions on that? All right. Are there any other trig formulas or trig functions besides sine, cosine, tangent, cosecant?
Cotangent?
Yeah, how about cotangent? And the nice thing, so by the way, again, I would never do this after Monday, but we have to because we don't know the big, huge theorem yet. There's a giant theorem happening soon. Okay, it is V1 in calculus, but we don't know it yet. So we just got to do it this way. So cotangent of x is the cosine of x over the sine of x. And that you should know. And I need to go d over dx. And guess what? Quotient rule. So we go ahead and we say low d high minus high d low. So sine of x times negative sine of x is negative sine squared of x. And then minus high d low cosine of x times the derivative of the sine of x, which is cosine squared of x. Square the bottom and away you go. Sine squared of x. And away we go. And what is that numerator? The hint is it's beautiful. What does the numerator become?
-1.
Yeah, -1. And -1 over sine squared is negative the cosecant. Squared of x. Any questions on that? And then finally, there's one more. What's the last trig function that exists?
Secant.
Yeah, secant. So let's do secant. So that's going to be the derivative of, who remembers what secant is?
1 over cosine.
Yep, 1 over the cosine of x. And that, again, quotient rule. Low d high is 0 minus high d low. Well, the high is 1, the d low is negative the sine of x, and it's a minus that. So it's just sine of x on top. Square the bottom, cosine squared of x. And away you go. And sine of x over cosine squared of x can be rewritten as sine of x over cosine x. That's tangent of x times 1 over the cosine of x, which is the secant of x. Usually you write that as a secant of x times a tangent of x. One thing that might help is notice all the ones that have cos in them are negative. Cosine, cosecant, cotangent, all of those are negative. For all the ones that don't have cos, didn't have the negative sign. So if you're trying to remember which one's negative, which one's positive, the cos are negative. Okay, there's a reason for that geometrically. That really comes on Monday, but it has to do with the there's a formula that says co-trig of theta equals trig of pi over 2 minus theta. And that's a complementary angle formula. And that minus comes out, it turns out, but we'll do that Monday. Any questions at all on any of the 6 trig functions? Okay, now comes a fun question. What is the 1/443rd derivative of the sine of x? Okay, this sounds painful, doesn't it? Do you want to take 143 derivatives? Given that we don't have that much time left? Probably not. But we could take a few and look for a pattern. So let's just do some. So let's do the first one. I can call it D1 even though you just write it as D. What's the derivative of the sine of x?
Cosine x.
Yeah, that you need to memorize. Cosine of x. Okay, now let's take the second derivative. And again, we're not going to have to do 143 of them. We do some. What's the second derivative of the sine of x? Negative sine of x. What's the third derivative of the sine of x? So that's the derivative of negative sine of x. Yeah, negative cosine of x. What's the fourth derivative of the sine of x? Yeah, the fourth derivative of the sine of x is the sine of x, and that's important because we're back. What's the eighth derivative of the sine of x? Sine of x. Okay, what is the 4,000th derivative of the sine of x? Sine of x. Every time you do 4 derivatives, you're back where you started. That's periodicity. All right, so in particular, all we need to do is we need to find the remainder of 143 when you divide by 4. So what is 143 divided by 4? Or in other words, let me write the computer science way of doing it. What is 143 mod 4? If you have any programmers in the group, you should know what that means. That means divide by 4 and only write down the remainder. So if you divide by 4, 4 times 3 is 12, get another 2, 2 times, then you get a 23, 4 times 5 is 20, and there's a remainder of 3. Any questions on that? Very important in computer science to understand modular arithmetic. Okay, so now we can answer the question. What's the derivative? What's the 143rd derivative of the sine of x?
Negative cosine x.
It's a negative cosine x because it's the same as the third derivative of the sine of x. So it's one of those, not that hard if you have a good strategy. But if you try to do this by literally taking 143 derivatives, you would give up because it'd be too boring. Y'all agree? But this isn't too hard as long as you understand that every 4 times you're back to where you started. Same is true of cosine x. You take the fourth derivative of the cosine x, you get the cosine of x. So it has a differential periodicity of 4. Any questions at all on these trig functions?
Yeah, can you explain the 143 mod 4 again? You lost me right there.
Okay.
So how are we getting 3?
Okay, so divide 143 by 4.
Mm-hmm.
So 143 divided by 4. And let's do it the first grader's way of doing it. And that is you write it down and you write down with the remainder. So we're not going to do decimals here. So 143 mod 4. 4 goes into 14 3 times.
Mm-hmm.
With 2 left over. 4 goes into 23 5 times with a remainder of 3.
Okay.
And that 3 in the remainder is what the mod 4, what the 143 mod 4 is. It means what is the remainder when you divide by that number. And this mod, this is the computer science way of writing it. And I figured, I know we have some computer science majors, so I want to make sure I bring it out for you guys. This kind of stuff comes up a lot in computer science. Okay, any other questions? I'm going to stop the share. And I'm actually going to stop the recording.